You want to see it or not? Okay. So they want the function to be continuous. What must you do? Limit. The limit from the left and the limit from the right. So how do I find limit? Which limit's the left? Top or bottom? So that's going to be x squared plus bx. And that's going to be the limit as we approach 5 from the left. And what must be true about these two limits? They must be equal. So this is going to be the limit as we approach 5 from the right. And that is 5 sine pi over 2x. So now what are we supposed to do from here? It goes fast if you answer my questions. We're going to substitute. So we're going to have, that's going to be 5 from the left, so that's going to be 25 plus 5b is equal to 5 times sine 5 pi over 2. Now, how do you do sine 5 pi over 2? What is that mixed number? 2.5. So that means we rotate 1. Remember, that's only 1 pi. That's 2 pi. And then we come up to a half. So that is a quadrantal angle. And that means that, what is that ordered pair on the unit circle? 0, 1. What's the ratio of sines in x, y, and r? Y over r. Good job. And so what's my y? 1. And what's my r? So do you agree that that's going to be 5 times 1? All right, so from here, it's just solving. So we're going to subtract 25, so we get negative 20. What is b? Negative 4. The answer is supposed to be C. We got it. What about number 2? Were you okay on 2? That's really current stuff. Oh, I'll do this. Yeah, I do, yeah. Okay, any questions on 2? Are we good on 2? All right, how about, what's the next one? 3? Oh, page 3, number 5. What about that one? Do you need that, or are you good on that? That's limits to infinity. Was that on your last test? This looked pretty intimidating, didn't it? Okay, if we look at this, what's the highest exponent of x in the denominator? 6. What's the highest exponent of x in the numerator? 5. So what are we looking for when we take limits to infinity? Horizontal asymptotes. How many people knew that? Okay. If you knew you were looking for a horizontal asymptote, since it's multiple choice, could you have used a shortcut? And what would the answer have been? It would have been 0. And why would it have been 0? So how did they make this look awful? Well, all those powers, that's ridiculous, right? Anyway, this is going to be 1 over x to the 6th. This is going to be 1 over x to the 6th. So this is going to be the limit of 10 to the 8th over x. And then this is going to be 10 to the 6th over x squared. This is going to be 10 to the 4th over x to the 5th, 4th. And the denominator is going to be 10 to the 9th plus 10 to the 7th over x plus 10 to the 5th over x cubed. And as we go to infinity, this becomes 0 plus 0 plus 0, which we're going to have 10 to the 9th plus 0 plus 0, which is just 0. All right, so that was number 5. What about page 4, number 6? Yes, sir. No, not on multiple choice, no. If you knew that was a horizontal asymptote, use that shortcut. Okay? All right, now it might not, I mean, yeah. On page 4, number 6. Are you good with that? All right, so you want to skip it then? If I don't hear someone say, please do it, we're moving on. Number 5, page 5, number 7. What about that one? Do that one. What rule is going to come first? We've got f of x. Did you write this as 4 sine x plus 2 raised to the 1/2? Did you? Okay. This is what you're supposed to find. What does this tell you have to do first? What kind of rule is this? Chain. How many recognize chain? Good. So did you say 1/2? Did you leave the inside just as it came to you? And did you remember your negative 1/2? So now, derivative of the inside, what's the derivative of sine? Cosine x. And then what happens to plus 2? So I don't want to evaluate this until I get rid of that fractional exponent. I find that very distasteful. So now we're ready to do f prime of what? 0. So do you need to be able to work with your trig? Yes. So cosine 0. This is 0. Let's see, this is the ordered pair 1, 0. What's the ratio for cosine? X over r. What is the x? 1 over 1. So we know the numerator is going to be 4. Denominator is going to be 2 times the square root. Okay, let's work on sine. It's going to be sine 0. So sine is y over r. What's my y? 0 over 1 is 0. So that's going to be 4 times 0 plus 2. So that's going to be 4 over 2 square root of 2, which is 2 over square root of 2. Was that one of their answers? No. So what do you need to be able to do? Rationalize. So you're going to get 2 square root of 2 over 2. Was that one of their answers? What do you have to do? Simplify. All right, page 6, number 9. How about that one? Is that a yes? Resounding yes. All right, so let's look to see what they're asking. They're asking an equation of a line tangent to the curve. We know we've got 169 equals x squared plus y squared, and we know we have an ordered pair 5, negative 12. If you're writing the equation of a line, what do you need? Slope and a point. All right, in this case, we need a very special slope. What kind of slope? Tangent. Do we have our point? That is 5, negative 12. So what are we going to have to do to find the slope of that tangent line? Implicit differentiation. What's the derivative of 69? 0. What's the derivative of 2x? I'm sorry. What's the derivative of x squared? It's going to be 2x what? Dx over dx plus 2y what? Dy over dx. So 0 is going to equal 2x plus 2y dy over dx. The derivative needs to be solved for. So we're going to subtract 2x and then do what? Divide by 2y. The 2 simplify. So you get negative x over y. How do I change this into a slope now? What do we do? So this is some notation you may see. Dy over dx, they'll have a line here, and then they'll have this. What does that mean? I'm going to evaluate the derivative at this point. So I'm going to have the opposite of x over y. What is my slope? 5 over 12. Riley, given the slope and given that point, how do we write the equation of the tangent line? Point slope, yeah. Good. All right. So now you look at your multiple choice answers and it's like, oh my goodness, that is nothing with what I see. So what does that mean you have to do now? You have to go further. On the free response, we would stop here. So you are going to distribute, and you're going to have 5/12 x minus 25/12. How do we get rid of, because there's no denominators in those answers, how do we get rid of the denominator? Okay, I lost my cursor. There it is. We're going to multiply everything on this side and on this side by 12. The good news on this side is the denominators are gone. So I have 5x minus 25. Over here, I need to distribute. So I have 12y, and 12 times 12 is 144. Now, before I go any further, I'm going to look at my multiple choice answers. Well, they put x first, and x is positive. Can you eliminate 3 of the 5 choices right now? So if their x's are first, that means everybody's going to get moved over here. Notice x's and y's are on one side, numbers are on the other. So that means I'm going to subtract my 12y and do what to 25? Add it. There it is, C. All right, what about page 9, 15, and 16? Do you need 15? Okay, if we're asking for concavity, JP, what do we need? We need second derivative. What's the easiest way to do this derivative? All right, there's no variables in the numerator, so this chain rule would be the easiest. So we're going to do first derivative, which is negative 2 times 4 minus x to what power? And what do you have to remember to do? Multiply by the derivative of the inside. So before I go for second derivative, this becomes positive 2, doesn't it? Oh, I didn't want to do that. This is going to be y prime is equal to 2 times 4 minus x to the negative 2. All right, second derivative is going to be what? 4 minus x to the, there's a minus there, negative 3 times what? But missing that negative one, would that mess up the whole problem? And that's to the third power. So now we're going to set this equal to 0, and we're going to get nonsense. We're going to get 4 equals 0. So then we're going to ask ourselves, where's the second derivative? What? It's undefined where? At x equal 4. So are you going to do a table? Because it's all about concavity. JP, what are your intervals? Negative infinity to 4. 4 to infinity. Test values. Okay. And we're testing this in our second derivative, and we're going to see what's happening. This is my second derivative. My numerator is always positive, so I'm going to focus here and here alone. So 4 minus 0 is positive. 4 minus 5 is negative. They want concave down. Which interval is it? Oh my goodness, I lost it. Let's find it again. Which interval? This is a day that has to be very, very good. This is our only day to review. All right. So it is 4 to infinity. Now look at the answers. They don't look like that. Which one of that says 4 to infinity? E. Any problems making that transition? What about 16? Okay, So we're given position. I can't express how important it is that we read these questions well. There you go. On this one it says the particle moves along the x-axis. That means that there's a horizontal movement on this particle in such a way that x of t is equal to 1 minus t over 1 plus t. We want the acceleration of the particle, acceleration, when t is equal to 0. How many derivatives is that? 2. What's the first derivative from position? It is velocity. So we're going to take the first derivative, and what rule are we going to use? From grading your test, those that brought this up with a -1 usually neglected to do the product rule. So it's safer to do the quotient rule. All right, this is not very happy, Smartboard. So there are how many other Smartboards open? Let me see if I get rid of some of these Smartboards, if it will help. All right. Maybe that wasn't a good idea. We're here. Pardon? All right. This cannot be. I think at the next break I might stop this video and maybe restart the computer just in case. All right, that's going to go. We do not want to save those changes. I'm afraid it's the wrong one. All right, and how's our video? Good to go. All right, let's see if it works better. So where do we begin the quotient rule? Who's first? We say denominator, which is 1 plus t. What's the derivative of the numerator? Okay, and then we're going to say minus the numerator. What's the derivative of the denominator? 1. All over the denominator what? Squared. So what do we need to do next? What are we going to do? Distribute our negative. We've got -1 minus t. We're going to distribute this negative. We have -1 plus t. Oh, this is going to be a nice second derivative. What happens to the t's? Oh no. It's not going to let me scroll. It's one of those days. All right. So we are going to, this is the t's cancel, and this is going to be -2 over 1 plus t quantity squared. Agreed? I don't think it'll scroll up here either. The smart software is being difficult. Oh! Okay. So now we're ready to, I'm going to look at, this was the first derivative. So this was the first derivative, and I'm going to rewrite this now. Why am I going to rewrite it this way, this time? Right, there's no variables in the top. So the second derivative is going to be +4, 1 plus t raised to the -3 times what? 1. So this is going to be 4 over 1 plus t raised to the third. And what did they ask us for? They asked us for acceleration, which is the second derivative, and they wanted the acceleration at 0. So now we're going to say 4 over 1 plus 0 cubed is what? 4. All right, how about page 12, 21 or 22? Let's start with 21. What about 21? Oh, did I prepare you for this question? Did you not just have a huge curve sketch worksheet? That's exactly why you had that. Were you all really good on that one? Nailed it. Good. All right. Ooh. What about the second one? What about 22? Did you need it? No? What are they asking you for? They're asking you for a second derivative. And what have they given you? This is number 22. They have given you a first derivative, which is x squared y squared. What kind of differentiation is this? It is implicit. All right. This is there we go. All right. There we go. Let's see if this works better. So I'm going to start this one over. What was it? dy over dx is equal to x squared y squared. And I think I heard you all say second derivative, so did everybody recognize that notation? What kind of derivative is this going to be? First of all, what rule do you have to use? Product. And what is this kind called? Implicit. So I'm not going to try to do all of this in my head. So now we're going to do y squared times d over dx. Don't want you. All right. So now we're going to say, what is the derivative of y squared? And what dy over dx? What's the derivative of x squared? 2x, and what did you just do? Dx over dx. So we've got x squared plus 2y. Just kidding. We have x squared times 2y dy over dx plus 2xy squared. Agreed? So now you go look and, oh my goodness, what's not in those multiple choice choices that's in my problem right now? Pardon? Yes, dy over dx is there. You see it? But how do I get rid of it? I'm right. Let me get a highlighter. We're going to plug in the first derivative, which is right here. And where are we going to put it? We're going to put it right there. So you're going to have, I lost my pen. Well, New Smart software didn't work very well, did it? So we've got 2x squared y times, substituting the first derivative, which is x squared. Do you remember doing this? Okay. And then that's going to be plus 2xy squared. So do you agree that's going to be 2x to the fourth y to the third plus 2xy squared? Now, is that there? I believe it is. All right, so that was page 12. What about page 14? Number, where is it? 25. Okay, what is this one called? It is a related circumference of a circle. What's the formula? They didn't give it to you. That's area. 2 pi r. Okay, so they're saying the circumference of a circle. That would be d. That's supposed to be a c. That's not even close to c. All right, that's supposed to be, well, that works too. We'll delete it. Oh, it didn't delete. Go figure. All right, so the derivative of c with respect to time is, it's increasing. I'm going to make that 1/2 meter per minute. Should that be positive or negative? It is increasing, right? Okay. What is the rate of change of the area of the circle? So area is equal to pi r squared. When the radius is 4, can I substitute 4 in right now? No, why? Why do we have to do the derivative first? Because a radius is not constant, it is changing. So we're going to go ahead and do this, and we're going to find out what we don't know. So this is going to be 2 pi r what? D r over dt. They are asking for the rate of change in area. We need this. Did they tell us our radius length? So this is going to be 2 pi times 4. What's missing? What don't we have? We do not have dr over dt, do we? Now, they usually don't give you superfluous, there's the word for the day, information. What did they give us we have not used? Our circumference, and what else did they tell us? What did they tell us? The rate of change of circumference. So we're going to do dc over dt is equal to what? 2 pi what? dr over dt. Do we know what dc over dt is? It is 1/2. So the question becomes, can you solve for dr over dt? How do you solve? How do we solve? Divide or multiply by the what? Reciprocal. Where is the pi in the dr over dt? It's in the where? Denominator. So now where am I going to put this 1 over 4 pi? Where are we going to put it? We're going to put it right there. So we have 1 over, oh, look how beautiful they make these multiple choice questions. Do you see how the arithmetic is easy? What is dA over dt? 2. So did they have 2? Yes, they did. All right, page 19. You need page 19, 34. Oh, I prepared you for this one too. Do you remember the abstract derivatives we did? Do you need this? Everybody did well on this? Okay, that is good. All right, how about 35? Okay, so let's talk about 35. Let me go to a new page. This is one of the ways they test you on all your theorems. It says f is differentiable. So we're going to stop right there. So I'm teaching you how to read. We got to the word differentiable, correct? What does that mean? What does differentiable mean? Okay, you can take derivative. What does that mean there is not? If you can take the derivative everywhere, what does it not have? It does not have everywhere. So it does not have any asymptotes. So doesn't that mean continuous is also a piece of this? But you can be continuous and still not be differentiable. What's the continuity that's not differentiable? You all know this. Sharp turn. That means if you can take the derivative everywhere, there's what? No sharp turns. Have I read anything else on this question? No. Your brain is this major, huge file cabinet. And you now have a file cabinet drawer called calculus. So what you've got to do when you go to do these problems is you've got to open up that file cabinet drawer, and you've got to pull the files that this problem involves. And what's one of these files? Differentiable. So what does it mean to be differentiable? All right. So then the next word I see, oh my, is increasing. What does that mean? What does this tell me? The function's increasing. It should be fresh in your minds too. Say that again. The derivative is greater than 0, also known as positive. All right, so this is all happening on our interval from 0 to b. And c is the number guaranteed by the mean value theorem. All right, so now I see mean value theorem. What do we know about the mean value theorem? So the slope of the secant is equal to the slope of the tangent. What does that mean? That means our algebra 1 slope is equal to our derivative. And where is this happening? At C. Which of the statements now must be true? So I can't scroll, so we're going to squeeze this in. For those people who are listening to this that were not here today, I can't scroll. We are crippled. All right. So f double prime of c is less than 0. What does this mean? Concave down. Anywhere in that green part, does anything guarantee concave down? It could be, right? It's a maybe. But is it a have to? No. So now what are they saying? They're saying f prime of c. So what is this? That's the slope of the tangent line, isn't it? At C. They're saying that that is going to equal f of b over b. Well, now, what do we know? We know the slope of the tangent line is supposed to equal what? The slope of the secant line, all right? Do you agree that these are x values? So if I wanted to do algebra 1 slope, this is what I want to check out. If I want to do algebra 1 slope, it would be f of b, right? Take away the y value at 0, all over b minus 0. All right, so I can see this. I can see that. Do you see that? This is the question. Just because x is 0, does that mean the y value has to be 0? Anywhere in the green did they tell us the y value is 0? It could be, but it might not be, so it can't be b. All right, so the next thing they told us is f prime of c is equal to 0. Again, what is f prime of c? Slope of the what? Tangent line. Okay, derivative is a slope-generating function of the tangent line. So they're telling us that the derivative at c is 0. Anywhere in that green, does that tell us that the derivative has to be 0? If they had said that there was actually, what in that green tells us it can't be? There is something there that says that's not possible. Not the differentiable. What did someone say over here? They said the function is what? Increasing. And if the derivative is greater than 0, how can the derivative equal 0? That is a contradiction, correct? Okay, that's probably the easiest one to see when you think about it. Do you see the importance of knowing this green and writing that down? All right, so now part D. Part D says the first derivative of c is greater than 0. What does this mean? Increasing. Did anything in green tell us this? Yes. Let's go ahead and look at D. So what, I mean, E, that's going to be the answer. But let's make sure. F prime, they're telling us that F prime of C changes signs. And why is that outright lie? Bold, in your face lie. Why can't that be? Right. If it changes signs, that means that it's going from positive to negative, so the function is going from increasing to decreasing, vice versa. And what do we know? It is what? Strictly increasing. So that word increasing really played a key piece here. All right. Do you feel better about that kind of problem? All right, the bell is about to ring, so what I'm going to do is I am going to stop this. I'm going to save. Did it stop? No. I'm going to save this. I'm going to shut down the computer, start it over so that we're good to go for the next, hopefully, 2 periods.